name is Ravi Prakash and welcome to second class of remainders. Okay, so we'll continue here from the first class. Let's do a few questions here. See, in the last class, the question which we did mostly we are finding remainders close to any power of plus 1 or minus 1. Okay, so all the questions, right now I'm not discussing any theorem here. All the questions you need to do like this. Okay, first get a comfort zone in remainders. For the questions you need to convert it to plus or minus 1 remainders kind of form. Okay, and because plus 1 raised to any power or minus 1 raised to any power will be plus 1 or minus 1 only in their respective cases, right? So we have to find the powers which are plus 1 or minus 1 in all the questions, right? Till we discuss theorems. Okay, Euler theorem or Chinese remainder theorem. Okay, so for example here, see, what we did in last video was something like this. Okay, that 18 raised to 100 divided by, or 18 raised to 100 divided by 19, what is the remainder? So now it's quite easy, I think. 18 by 19, the remainder is minus 1. Minus 1 raised to 100. Okay, minus 1 raised to an even power is plus 1. So 1 is the answer. Okay, then 27 raised to 20, or I should write in 27 raised to 281 divided by 28 remainder. Okay, so 27 by 28 remainder is my minus 1. Minus 1 raised to 281. So now minus 1 raised to an odd power, minus sign retains, it is minus 1. Okay, but in remainders final answer is never negative. Always write the positive corresponding remainder. So for this whole number divided by 28, the negative remainder is minus 1. What is the positive corresponding remainder? Okay, so how to get it? Just add this to base with sign. Base is 28, negative is minus 1. So 28 minus 1 is what? 27. So 27 is the answer for this question, right? We discussed this, right? Now we'll move one step forward and then we'll, right now it can be easily seen that 27 by 28 or 18 by 19 remainder is plus 1 or minus 1. Okay, now we have to search for those things, right? In the next question we have to search for those things, right? Now see how to search it. If I take example here, 2 raised to 185 divided by 33 remainder. 2 raised to 185 divided by 33 remainder, right? So directly seeing this question it is difficult to solve. Okay, but once you understand the concept of that, always in remainders we are looking to find remainder to be plus 1 or minus 1. So that plus 1 power anything or minus 1 power anything, right? It doesn't bother us because it is very easy. 1 power anything is 1 only. Minus 1 power anything, or it's in two cases, right? Minus 1 power odd is minus 1. Minus 1 power even is 1. So that's why I'm always converting to plus 1 or minus 1. So that this power rule is finished here. Power's rule is finished here. So 2 raised to 185 divided by 33 remainder. Okay, 2 raised to 185 divided by 33 remainder. So I have to search here, right? I have to search here that powers of 2, okay, and 33. When I'll get remainder of plus 1 or minus 1. I have to search for few powers of 2. I have to look for few powers of 2, and that divided by 33. when I will get remainders of plus or minus 1, right? So obviously till 2 raised to 4 is 16, there's no chance because all the powers of 2, 2 raised to 1, 2 raised to 2, 2 raised to 3, 2 raised to 4 all are much less than 33. So I will never get remainder as plus or minus 1. I have to look for the close numbers in 33 or in multiples of 33, right? In 33 or in multiples of 33. Because why in multiples of 33? Because 34 by 33 remainder is also plus 1. Okay, and 33 next multiple is 66. So 67 by 33, that remainder is also plus 1. So 33 to just 66, 33 1 33. So I can look near to the multiples of 33 as well. So I have to look for powers of 2 that are close to 33. To search here, right? I have to search here that powers of 2, okay, and 33. When I'll get remainder of plus 1 or minus 1. I have to search for few powers of 2. I have to look for few powers of 2 and that divided by 33 when I will get remainders of plus or minus 1, right? So obviously till 2 raised to 4 is 16, there's no chance because all the powers of 2, 2 raised to 1, 2 raised to 2, 2 raised to 3, 2 raised to 4 all are much less than 33. So I will never get remainder as plus or minus 1. I have to look for the close numbers in 33 or in multiples of 33, right? In 33 or in multiples of 33. Because why in multiples of 33? Because 34 by 33 remainder is also plus 1, okay, and 33 next multiple is 66. So 67 by 33, that remainder is also plus 1. So 33 to just 66, 33 1 33. So I can look near to the multiples of 33 as well. So I have to look for powers of 2 that are close to 33 or near to the multiples of 33. Okay, right. So is it close to 33? See, 2 power 5. If you observe it, 2 raised to 5 is 132. Okay, if you observe it, 2 raised to 5 is 132. Let me write here. 2 raised to 5 is, 32, not 132. I'm sorry. Okay, so 2 raised to 5 is 32. So that means the number here, the number 2 raised to 5 is 32 and 32 by 33 will give me a remainder of minus 1. So how I should write? I should write like this. 2 raised to 5. 185 should be written as 2 raised to 5. Now what is 185 by 5? Dividing by 5 very easy. Just double the number. 185 double 370 and put a decimal on the last digit. So 185 double 370, put a decimal 37. So that is 37. 5 into 37 is total 185 divided by 33 remainder. Okay, so that means what? What I have written is 2 raised to 5 into 37. 2 raised to 185. Okay, is written as 2 raised to 5 into 37. Why so? Because 2 raised to 5 is 32 and 32 raised to 37 by 33. Now it becomes an easy question for us, right? Because 32 by 33 remainder is minus 1. Minus 1 raised to 37. Okay, it is minus 1 only. But negative, it is finally negative remainder and final answer has to be always positive. So what is the corresponding positive remainder for minus 1? Okay, so just add to base with sign. Base is 33, negative remainder is minus 1. So 33 minus 1, just add it. So what is the answer? 32. So 32 is the answer for this question, right? Therefore, 2 raised to 185. 2 raised to 185 by 33. What is the remainder? Remainder is 32. 32 is the answer. 32 is the answer, right? I hope you got it. Okay, so this is a very nice funda of solving this kind of question. Okay, now let's do some more. I can take another example here. 2 raised to, now after this I can take 2 raised to 187 by 33 remainder, right? Slight twist. Why slight twist? Because in the last question it was 2 raised to 185. It was a multiple of 5. What if the number is not a multiple of 5 and the number which I am getting for plus minus on remainder is has to be a 5, power 5, right? Like here I know that 2 raised to 5. I know that 2 raised to 5 is 32 and 32 by 33 has to be minus 1. But it cannot be easily broken, right? Because it's 287. In last question it was 185. I easily wrote there 5 into 37 as 185. But here I can't write. So I know that I had to break in multiples of 5. So what I will do? I'll just pick a multiple of 5 that is just before 187. I'll pick a multiple of 5 that is just before 187, that is 185. So I'll write like 2 raised to 185 into 2 square. I can split like this, 2 raised to 185, 5 to 2 square. So 185 plus 2 will become 187. Fine. That divided by 33. Why? Because I have to write this in powers of 2 to get the remainder of minus 1 or plus 1. Okay, because 32 is 2 raised to 5. Now I can solve like this. So I can solve similarly. 2 raised to 185 can be written as 2 raised to 5 into 37, okay, into 2 square divided by 33 remainder. Correct. And now 32 by 2 raised to 5 is 33. 32 by 33 remainder is minus 1. So minus 1 raised to 37. Okay. 4 by 33. 2 square is 4. 4 by 33. Remainder is 4 only. Right? A small number. 4 by 33 remainder is 4 only. You can take 4 here. Minus 1 raised to odd power. It remains minus 1. Minus 1 into 4 becomes minus 4. But final remainder is never negative. I should stop at 4 because 4 is lesser than magnitude, lesser in magnitude than 33. That's why 4 is correct, right? But I have my minus sign here. So minus 4 base, I have to add to base with sign. So 33 minus 4. What is the answer? Answer is 29. Answer is 29. Right. You can do one more thing here. Instead of minus 4, 4 by 33. You can also write minus 4 by 33. Positive remainder is plus 4. What is the negative remainder? Minus 29. Because 4 is 29 less than 33. So I can trick. You should not put minus 29 because I am favoring a lesser magnitude here. But it's no issue, right? Even if you put no issue. Minus 29. Okay. So here the remainder is minus 1. Okay. Here the remainder is minus 1. And here what is the remainder? Minus 29. So minus 1 into minus 29 becomes what? Becomes 29 only. Right. So I told you. Just play with numbers. It's absolutely your wish, right? Not mine. It's absolutely your wish, right? You can just play with the numbers, positive remainder, negative remainder. Okay, and you can get all those concepts clear, right? Now, we'll do again one more example. See? Okay. Now let's take this example here. 2 raised to 404 by 17. What is the remainder? So again, right? What I look for? I'll always look for this number to be remainder to be plus 1 or minus 1 something, that I want plus 1 or minus 1 something. Okay, so again I'll look at the powers of 2 and I'll look at 17 all multiples of 17 to see the difference as plus 1 or minus 1. So I can see quite easily that 2 raised to 4 is 16. Okay, so if 2 raised to 4 is 16, so I can write this number as 2 raised to 4 into 101. 404 by 4 is 101. So I can write this number as 2 raised to 4 into 101. That is 404 only. Right? Divided by 17. Okay? Now 2 raised to 4 is 16. It becomes 16 raised to 101 by 17. 16 by 17. What is the remainder? Remainder is minus 1. So minus 1 raised to 101. Okay? Power is odd. So minus sign retains.
Hi Rishabh.
But final answer has to be positive. What is the final answer? This is plus 17 and this is minus 1. So plus 17 minus 1. What is the answer? Answer is 16. Answer is 16. So 16 is the answer for this question. 16 is the answer for this question. Correct? Now if I write like this here, 2 raised to 410 by 17. What is the remainder? Okay. The same thing, right? I know that 2 raised to 4 is 16. Okay. So to convert in multiples of 4, but 410 is not a multiple of 4. So what to do? Just pick a number before 410.
Yeah, I slept, but I was knowing something will happen.
That is a multiple of 4. So that is 408.
I also woke up to see if anything has happened or
2
not.
raised to 408 and 2 further is left, so 2 is square. Okay? Such that 408 plus 2 becomes 410. Divided by 17 remainder. Correct? Now 2 raised to 408 into 2 is square. Right? Now 2 raised to 408. So why I have done this? Because 2 raised to 4 is 16. So I can write 408 as 2 raised to 4. 408 by 4 is 102. Okay. So 408 is 2 raised to 4 into 102 into 2 is square. Divided by 17. Okay. Now this becomes what? This becomes 16 by 17. Remainder is minus 1. So it becomes minus 1 raised to 102 into 4. Minus 1 raised to 102 into 4. Okay. Divided by 17, of course. Right? So minus 1 raised to an even power is 1 and into 4 is 4. So 4 by 17, remainder is 4 only. So 4 is the answer, right? It is not, it is nowhere negative sign, right? So I don't need to convert anything. Simply 4 is the answer. Okay, so 4 by 17, 4 is the answer. Okay, so another good example of this is splitting the terms and all, right? So I hope this part is clear to you. Okay, all this concept. Okay, now let's move to a different concept here. Okay, so the next concept is of cancellation factor, right here. Cancellation factor, right? Another very useful application in remainders, cancellation factor. Okay, now see what is cancellation factor here. See, for example, if I try to find a remainder of 20 by 15, right? 20 by 15. What is the remainder? So quite easy. 15 minus 15, remainder is 5. Okay. But what you can do sometimes is just cancel the number, right? 20 by 15, and again cancel. Okay, 5. I have to find the remainder here, and 5 4 is 20, 5 3 is 15. So it becomes 4 by 3 remainder. Okay. So 4 by 3 remainder is 1. Okay. So it might not look good here, right? But in the bigger questions, we tend to apply these things where we see that numerator and denominator can be cancelled. Okay, and this is a big mistake, right? You can see we got different answer here, right? Because question was 20 divided by 15. What is the remainder? And you converted to 4 divided by 3. What is the remainder? So we can't do this, right? This is wrong. This is wrong way of doing it. Okay. Now, when to divide it, right? Suppose I write it the question as 20 by 10, what is the remainder? So here you can easily see, right, that 20 completely divides 10. So no sense of remainder here, right? Because 20 completely divides 10, sorry, 10 completely divides 20. So 20 by 10 completely divisible. What is the remainder? Remainder is 0. Remainder is 0, right? Because in this case, it is completely cancelled, so remainder is 0. Fine. So, but in many questions, right, it is like some cases we have to cancel it. We have to cancel it, okay, and there is no other way of solving it, or it's a very tough way of solving it, right? But after cancellation, it becomes very easy. So how to use this cancellation factor concepts and remainder? See, understand it. See, this example if I take here, 20 by 15, what is the remainder? So if I can see a common factor in numerator and denominator, that is 5 here, I can cancel it. 5 3 are 15, 5 4 are 20. But simply remember that cancellation factor, right? That your cancellation factor is 5. You have cancelled by 5. 5 4 are 20, 5 3 are 15. You have cancelled by 5. Okay, so 5 you have cancelled from both the numerator and denominator. So you are left with 4 by 3. It's okay. 4 by 3 remainder is what? It is 1. Okay, but always multiply your answer by cancellation factor. That is 1 into 5. Your answer will become 5. So 5 is the answer, right? It is correct. 5 is the answer. Not 1, but 5 is the answer. Why 5 is the answer? Because we have again we got 4 by 3 remainder as 1, but we have again multiplied by this cancellation factor here. Okay, that will give me the correct answer. This is the concept of cancellation factor, right? For example, 100 by 40. What is the remainder here? So 40 2 ja 80. Remainder is 20. Correct? If I try to cancel it, 100 by 40 remainder, and I try to cancel it, so can cancel it, no issue. 22 ja 40 and 25 ja 100. So if cancel 20, just remember that our cancellation factor is 20. Okay. Now 5 by 2. What is 5 by 2 remainder? So 5 by 2 remainder is 1. Correct. Remainder is 1. 2 ja 4 remainder is 1. And just multiply that 1 final answer with the cancellation factor. So 1 into 20 again becomes 20. Right. So very important concept of cancellation factor here. Very important concept of cancellation factor here. Right. Now see.
Liquid Text, winner of Apple's Editor's Choice Most Innovative iPad App of the Year, goes beyond.
What is the remainder? 7 raised to 777 by 28. What is the remainder? This question becomes tough, right? If I don't cancel the common factor. Okay, but as soon as I cancel it, this question becomes very easy. This question becomes very easy, right? What I want to show here is, we can observe that numerator and denominator both have got a the multiple of 5. What if the number is not a multiple of 5 and 4 by 33 remainder is 4 only? Then take 4 here. Just pick a number before 410 and closest to 410, that is a multiple of 4. That is 408. So I can write this number as 2 raised to 408 and 2 further is left, so 2 is square. 20 by 15, right? 20 by 15. What is the remainder? So quite easy. 15 by 15, remainder is 5. Okay? But what you can do sometime is just cancel the number, right? 20 by 15 and again cancel, okay, 5, I have to find the remainder here, and 5 4 is 20, 5 3 is 15, so it becomes 4 by 3 remainder. Okay, so 4 by 3 remainder is 1. You can easily see, right, that 20 completely divides 10. 5 here, I can cancel it. 5 3 is 15, 5 4 is 20. But simply remember that cancellation factor, right? That your cancellation factor is 5. You have cancelled by 5. 5 4 is 20, 5 3 is 15. You have cancelled by 5. Okay, so 5 you have cancelled from both the numerator and denominator. So we are left with 4 by 3. It's okay. 4 by 3 remainder is what? It is 1. Okay, but always multiply your answer by cancellation factor. That is 1 into 5. Your answer will become 5. So 5 is the answer, right? It's correct. 5 is the answer. Not 1, but 5 is the answer. Why 5 is the answer? Because we have again we got 4 by 3 remainder as 1, but we have again multiplied by this cancellation factor here. Okay, that will give me the correct answer. This is the concept of cancellation factor, right? For example, 100 by 40. What is the remainder here? So 42 ja 80, remainder is 20. Correct? If I try to cancel it, 100 by 40 remainder, and I try to cancel it, so I can just cancel it, no issue. 22 ja 40 and 25 ja 100. So if cancel 20, just remember that our cancellation factor is 20. Okay? Now 5 by 2. What is 5 by 2 remainder? So 5 by 2 remainder is 1. Correct, remainder is 1. 2 to 4, remainder is 1. And just multiply that 1, final answer with the cancellation factor. So 1 into 20 again becomes 20. Right. So very important concept of cancellation factor here. Very important concept of cancellation factor here. Right. Now see some good remainder question with this concept. Suppose the question here is 7 raised to 777 by 28. What is the remainder? 7 raised to 777 by 28. What is the remainder? This question becomes tough, right? If I don't cancel the common factor. Okay, but as soon as I cancel it, this question becomes very easy. Right? What I want to show here is, we can observe that numerator and denominator both have got a common factor of 7, right? Numerator is also multiple of 7, since it is the power of 7 only, and 28 is also multiple of 7, right? So what we should do here is simply cancel it, right? Simply cancel 7. So if I cancel 7 from numerator and denominator, what I will get is, so in numerator there are 777 sevens. If I cancel 1 7, I will be left with 776 sevens. That is 7 raised to 176, 776 divided by 4. Because I have cancelled 7, 7 4 is 28, and 7 goes 776 times to left here 7 raised to 776. But remember, always write here that our cancellation factor is 7. So that to finally multiply with that, right? Now it's very easy, no? It was looking tough here, but now it is very easy, no? Right? Because 7 by 4 remainder is 3. 7 by 4 remainder is 3. 3 raised to 776. Okay? 7 by 4 remainder is 3. 3 raised to 776. Now 3 raised to 776 is a number which is more than 4. I should again divide by 4. Okay? Now 3 by 4 remainder is what? Remainder is minus 1. So minus 1 raised to 776. Okay? That minus 1 raised to an even power becomes 1. Okay? But never write the answer as 1. Always multiply the, after cancellation, always multiply the final answer with 7. Okay? But that is the cancellation factor. I have cancelled by 7. Okay, so 1 into 7. 7 is the answer. 7 is the answer. Right, so another beautiful application of cancellation factor in remainders. Right, very good concept. Okay, now see one more question here. 3 raised to 159 divided by 30 remainder. Again, looking like a tough question here, right? But I can see that here both numerator and denominators are multiples of 3. Just cancel 1, 1, 3. Cancel 3 from numerator, cancel 3 from denominator. So this goes 10 times, right? So what is left here is, in denominator we are left with 10. In numerator we are left with 3 raised to 158. 159 3s are there, have cancelled 1 3. So 158 3s are left. Okay? Now this I don't need to find here, but always remember that cancellation factor is 3. Have cancelled by 3, but to multiply at last. Okay. Now 3 raised to 158 again, right? What I'm looking for is remainder to be 1 or minus 1, right? All those concepts of remainder apply here. That's it. One step is gone. Cancellation factor. Now back to normal remainder question. If this was a normal remainder question, what would you do? You'll divide this 3 raised to 158 divided by 10. Okay. So what you'll do? You'll find the remainder to be, don't forget, right? Plus 1 or minus 1. Now look at powers of 3 and look at 10 or multiples of 10. Where do you get a difference of 1 or plus 1 or minus 1? Quite easy, because 3 square 9. Powers of 3 close to 10. 3 square is 9. Quite easy, right? So I can convert it like 3 is square. I can write 158 as 2 into 79. Divided by 10 remainder. Okay? 9 by 10 remainder is minus 1. Because it's just because what? It becomes like this. 9 raised to 79 by 10. Okay? So 9 by 10 remainder is minus 1. So minus 1 raised to 79. Minus 1 raised to an even power remains minus 1 only, right? That is minus 1. Okay. Multiply with 3. Okay, because now right now I can't further arrange. So multiply with 3. So now multiply the cancellation factor, that is 3. So minus 1 into 3, answer is minus 3. But final answer has to be always positive. So always add a base with sign. What is the base here? 30. 30 minus 3. Answer is what? Answer is 27. So 27 is the 27 is the answer for this very nice question. 27 is the answer for this very nice question. Correct. Now you can always write. This can come to your mind that what if I can replace minus 1 here only? So you can replace minus 1 here, no issue, right? Minus 1 you can write instead of minus 1 is to 179. Sorry, minus 1 is to 79. It remains minus 1 only. Okay, and you can convert here only, but remember that you are right now you are solving 9 raised to 79 by 10. You are not solving this, right? You have already cancelled 3. This is a new question. So don't replace this minus 1 with 30 minus 1 29. No. Right now you are solving for this question, right? You have cancelled 3. This is a new question. So 9 raised to 79 by 10. Right, so remember the base here is 10. So 10 minus 1, you should write 9 here. So instead of minus 1, you can write 9 here, and 9 into 3 becomes 27. That is your answer. Same thing, right? That also you can do. It's absolutely your wish. I told you, no? You can just play with numbers, right? Absolutely no issue. You just play with the numbers. Okay? I hope it is clear, right? So another good concept of cancellation factor we have discussed, right? One more example we can do, just for practice. 5 raised to 160 divided by 5 raised to 160 divided by 20. What is the remainder? Correct. So again I can see here, in numerator and denominator both are multiples of 5. Just cancel 1 5 here. So left with 5 raised to 159 divided by 4 remainder. Okay. And always remember that your cancellation factor is 5. Correct. So quite easy now. 5 by 4 remainder is 1. 1 raised to 159 is 1 only. Right? And 1 into this cancellation factor 5. 1 into 5. What is the answer? Answer is 5 only. Answer is 5 only. Right? So 5 is the answer for this question. Okay? I hope it is clear right now. So all this part is clear. So this is the concept of cancellation factor. Okay. So in next video, we'll discuss further about remainders, Euler's theorem and all. Okay.
Moving towards remainder 3.
and welcome to third class of remainders. So here we'll discuss about Euler's theorem. Okay, Euler's theorem, very important for remainders, right? For solving remainders in very less time, Euler's theorem. Okay, so for that we need to learn about how to calculate Euler number. Euler number, very important concept. How to calculate Euler number. Okay, so calculating this Euler number, right, is a direct formula to calculate it, but we'll see the proof because it's an important concept of quant also, and then you can use this funda as a Euler number in Euler number, calculating Euler numbers, right? So what is Euler number basically? So you see, what is Euler number? Euler number is basically numbers before n that are coprime to n. We know what is coprime numbers? Coprime numbers means numbers having nothing in common. In common language, nothing in common. That means numbers like 4 and 9 are coprime numbers. They have nothing in common. Numbers like 5 and 6 are coprime numbers having nothing in common. That means their HCF is 1. Their coprime numbers means their HCF is 1. Right. Numbers like 12 and 10. These are not coprime numbers. 12 and 10 are not coprime numbers. Why? Because 12 and 10 has got 2 in common. So not coprime numbers. What are coprime numbers? Having nothing in common. So numbers before n that are coprime to n, right? So for this, we'll understand this concept here. Okay, then we'll derive the Euler formula for calculating Euler number, right? I'm just asking you, right? Just see this series of questions here. Just try to answer it, and then automatically our Euler number formula will be derived. Okay, numbers from 1 to 30 that are not multiples of 3. How to solve it? I want numbers from 1 to 30 that are not multiples of 3. How many such numbers are there? How many numbers from 1 to 30 are there that are not multiples of 30? So see, I can easily answer it. Mentally I can do it. That 33 multiples of 3 till 30. 10 multiples, right? So 10 multiples. So what is my answer? 30 minus 10. 1 to 30. There are 30 numbers and there are 10 multiples of 3 till 30. So subtract those 10 numbers. So 20 is the answer. Right. So what is the way of writing? The way of writing would be numbers which are multiples of 3. Okay. Numbers which are multiples of 3 is how much? You can directly write it as 30 by 3. That is 10. So 30 by 3, right? 30 by 3. Numbers which are multiples of 3, 30 by 3. 1 to 30. How many numbers are multiples of 3? 30 by 3. 10 multiples, right? Quite simple. So numbers which are not multiples of 3. Therefore, numbers which are not multiples of 3. Which are not multiples of 3 will be how much? Total 1 to 30, there are 30 numbers. 30 minus 30 by 3. 30 minus 30 by 3. That is how much? So 30 minus 30 by 3 can be written as 30 into 1 minus 1 by 3. Okay. Can be written as 30 into 1 minus 1 by 3. 30 minus 30 by 3 can be written as 30 into 1 minus 1 by 3. Right. So you can directly write numbers from 1 to 30 that are not multiples of 3. What is the way of writing? Directly I can write it as 30 into 1 minus 1 by 3. That basically means that numbers which are not multiples of 3. Okay, understand this, right? Now, come to next one. So can I directly write that numbers from 1 to 50 that are not multiples of 5. How many numbers from 1 to 50 are there that are not multiples of 5? What to write? You can simply write same thing. 50 by 5 will be multiples of 5. So how many are not multiples of 5? So 1 to 50 there are 50 numbers. So 50 minus 50 by 5. That is 50 into 1 minus 1 by 5. Once you solve there, you will get answer as 40 only, right? Because you do it mentally. 1 to 50 there are 10 multiples of 5. And so from 1 to 50, 50 numbers, subtract those 10. 50 minus 10, 40. But what is important for me is this way of writing to derive Euler number formula. Okay. So numbers from 1 to 50 that are not multiples of 5, 50 into 1 minus 1 by 5. Okay. Numbers from, right here, numbers from, right, 1 to 30, we just discussed, that are not multiples of 3. Directly I can write it down now. What is it? 30 into 1 minus 1 by 3. So 30 into 1 minus 1 by 3 is what? Numbers which are not multiples of 3. Okay. Now, one step ahead. Okay. Numbers from 1 to 30, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 numbers. So we got this concept, right? This is the concept. The moment we write this kind of statement, it is able to relate what I am writing. Okay. So similarly I can write numbers from 1 to 60. How many numbers from 1 to 60 are there? Which are
So guys, we'll continue from here tomorrow.